No day passes without a news story about some aspect of energy: its price, security of its supply, the need for energy efficiency, concern for those suffering energy poverty, expediting the energy transition. Energy is bought and sold in enormous quantities for stupendous sums of money. Business people, politicians, and homeowners have no doubts that energy is a real thing that can be bought and sold for hard cash like gold or milk. And yet, in reality, it is a very subtle concept that took a good 2 centuries to emerge from the intellectual haze. And for much of that time, it was confused with entropy. Energy and entropy were conjoined twins that nobody was able to separate. Entropy is arguably a no less important concept than energy, yet most people without a degree in physics or chemistry will not have heard of entropy, and probably a few of those with relevant degrees could explain what entropy is with any clarity. The story of how energy and entropy emerged has no absolutely clear beginning, but a reasonable starting point is the appearance in 1687 of Isaac Newton's epical work on mechanics, Mathematical Principles of Natural Philosophy. It showed how the trajectories of moons, planets, and projectiles could be computed. Kinetic energy, the energy that a body has by virtue of its motion, is implicit in the mathematics that Newton presented, but Newton and his contemporaries largely overlooked it. In 1680, the German mathematician Gottfried Leibniz, 1646 to 1716, did note that when bodies interact, the sum of what we would call their kinetic energies is sometimes conserved, but frequently it is not conserved for reasons that remained unclear until the middle of the 19th century. Leibniz's conserved quantity was the sum of masses times speed squared, and a body's contribution to this sum, mv squared, acquired the name vis viva, Latin for living force. Vis viva attracted attention steadily over the century from Leibniz's remark. In 1715, the Swiss mathematician Johann Bernoulli, 1667 to 1748, developed the related concept of work, force times distance, through which bodies acquire vis viva. While savants, the word scientist had yet to be coined, were puzzling over work and vis viva, mining engineers in Cornwall and northeast England were pioneering steam engines to drain mines and to lift and move coal. A steam engine uses heat to do work and create motion, and thus connects heat to vis viva. Conversely, any carpenter knows that a drill bit becomes warm when boring a hole, so heat can emerge when work is done.